Okay, so we're going to look at oblique asymptotes, and that's when we have these types of rational functions. Yeah, okay. We're looking at if we were to graph something like this, and one way we'll be looking at it is we can look on a graphing calculator, take a look at what this would look like, and we get this relationship here. And essentially is we're getting an asymptote that looks like it's probably linear, and it probably follows a line like this, but we want to find out exactly what the asymptote is. We're very used to solving for horizontal and vertical asymptotes. So what if we have a slanted asymptote? What is it that we do? Well, the process of this would be actually carrying out this process of division. We'll divide our first function, this kind of quadratic, by this linear, and whatever our resulting answer is, minus the remainder, will give us the equation of whatever our linear asymptote is from the function that we were looking at. So let's carry this out. I'm going to set up long division here. So we have x minus 2, and we have x squared minus 3x minus 4. Okay, so if we're doing our long division here, we're always focused on the very first term. We have our x and our x squared. So in order to get that x squared, we need to multiply by a value of x. Okay. And when we multiply x by both of these, we're going to get x squared. I guess maybe I'll write that in blue here. So we multiply all of them, we get x squared, and x times negative 2 gives us negative 2x. So we then go about subtracting to find out what we get. Our x's cancel each other out, so essentially 0. I don't really need to write anything out. And this is negative 3 minus negative 2. So it's like adding. Okay? So this actually ends up being negative x in this case. And we bring down our negative 4. Okay. And in this one, we'll have to figure out how this now goes into here. So again, we look at our first term, our x and our negative x. So in order to eliminate that term, I need to multiply this x by negative 1. That'll give me the same term there. So I multiply by negative 1. Okay. And when I multiply negative 1 by our terms here, I'll get negative x and positive 2. Okay. So we just carry out this process here. We go to subtract. So negative x minus negative x is like negative x plus x, which gives us 0. And negative 4 minus, and I guess I should put those in brackets because that's our long division style. The negative 4 minus positive 2 is like negative 4 minus 2. So we can actually get negative 6. So we have a remainder of equal to negative 6. So if we were to write this equation out as if we have just divided everything, what we end up having is our g at x is equal to our x minus 1, and I'll put it in red. Okay, so that's what we had there, our x minus 1. And we have our remainder divided by what we were dividing the entire equation by. So negative 6, so we'll underline it, divided by this. So that would look like minus 6 over x minus 2. But so it's really important to find our oblique asymptote. Okay, it's actually this part of our equation here. It's our x minus 1. So this gives us our oblique asymptote. So we'll underline it, is the equation. Sorry, I wanted the pen. There you go. So our OA, our oblique asymptote, we'll call it, is y is equal to our x minus 1. So we'll go over to our graphing calculator, what we're looking at before, and we'll plug this value in. Y is equal to x subtract 1. And I guess we can zoom out, and that's probably not the best one. Maybe if we zoom in, it'll be a little better. We can see that it's essentially following this line. If we were to continuously follow it up, we would see we get closer and closer, but never really touching that value. And then in the exact same idea, that same opposite direction, it gets closer and closer, but never really touches that value. So we really just carry out our rational function. We carry out the division, and the first part of our equation is giving us what our oblique asymptote actually is. So let's go entire page here.